All right, so let's talk about compound inequalities. So we'll start with and inequalities. Okay, say we have the problem -4 is less than 6x minus 10 is less than or equal to 20. So it's a compound inequality. It's an and type of inequality. The variable is in between the two less than signs. So that means it's a shared solution. So what we want to do is we want to get the variable to be by itself, even though it's in the center. So first thing I would do if it was a regular inequality would be to add 10 to both sides. And since we have 3 locations, we're going to add 10 to the left and to the right. So then on the left side, we have -4 plus 10, and that equals 6, is less than. In the center of the compound inequality, we have a 6x left now, and we have that less than or equal to 14 plus 10 is 24. And again, we want to get the x in the center to be by itself. So what we will do then is divide everything by 6. And then we're going to divide both sides by 6. 6 divided by 6 is 1. So 1 is less than x is less than or equal to 1. So let's graph that inequality on a number line. It's saying the solution is between 1 and 4. And so 1, it says x is greater than 1 or x is less than or equal to 4. And x is less than or equal to 4. So 1 gets an open circle because it does not say or equal to. And 4 gets a closed circle because it does say it's equal to it. So that means it's included. And an and inequality, we're going to shade the center. So that's how we do a compound inequality when it's an and. Let's do one more. This one we're going to do is -10 is less than 3x plus 5 and is less than or equal to 8. So again, we want to get the x in the middle by itself. So I'm going to subtract 5 everywhere. And that will get me -15 is less than 3x is less than or equal to 3. And then I divide everything by 3 in the center. And that gets me -5 is less than x is less than or equal to 1. And on a number line, we'll include those numbers. All right. And -5 does not have an or equal to part, so it's an open circle. 1 does say or equal to, so it's a closed-in circle. It's included in the solution, and the rest of the solutions are in between those two numbers. And I will put that back. Okay, so that's how you do and inequalities. Now let's talk about some or compound inequalities. Now, ors have to say the word or in the problem. So you know you have an or inequality rather than an and inequality if it says or in the problem. So for example, we have 3x plus 5 is less than or equal to 11. And then it says the word or 5x minus 7 is greater than or equal to 23. And when you solve an or inequality, it's really quite simple. You just solve the inequality separately. So I'm going to treat that 3x plus 5 is less than or equal to 11 just like it's its own separate problem and work it first. So I'm going to subtract 5 on each side. 3x is less than or equal to 6. Divide by 3. And x is less than or equal to 2. And what I like to do is go ahead and put or with my answer after I write the first one just so I don't forget it, because or problems also need to have an or in their answer. And then on the other one, I just completely solve it like its own separate problem too. So I'm going to add 7. So 5x is greater than or equal to 30. Divide by 5. And x is greater than or equal to 6. So that's my solution. And then if I want to graph it on a number line, Remember the oars shade in opposite directions. And 2 is a closed circle because it says less than or equal to 2. So it's included in the solutions. And I'm going to shade to the left. And then x is greater than or equal to 6. 6 is included in the solution because it says or equal to, so it gets a closed circle. So hopefully this video will show you how to do and or inequalities. And I hope you have a great day.